Hey everybody, today we'll do another video and today we'll do another differential equations video and and we will do what is called initial initial value problem. This marker is not really helping. Let me see if I can find another one that works a little better. So called initial value problem. So it's a good thing to kind of, when a problem is given, right, in differential equations, or what is called also, ODE, ordinary differential equations, right? So basically, so when a problem is given like this, we know the derivative is going to be given, right? Differential equations. And an initial value problem means that an initial condition has been given to us. For example, if you have an algebra, you have somebody tell you to evaluate evaluate um, the function of f of x equal to x squared, right? Then and set at x equal to, well, you plug that in and you know it's going to be a parabola centered at 0, right? It doesn't have any y-intercept, right? It doesn't have any intercept. So the intercept that has 0, right? At the moment, it's just 0. So in other words, doesn't have any, what I'm trying to say doesn't have any shift, right? So what you do is you put 2 f of 2, all right, at this value, evaluating at that is going to be 2 squared, which is equal to 4, right? Then at x equal to 1, 2, right? And that point will be around about there, and it's going to be the value at this point is going to be 2 comma, your value for y is going to be 4. So the solution for this is going to be 2 comma 4. Right? The same thing with differential equations. The only thing, obviously, is the differential equations are a little more complicated to do. The different level of mathematics, a little higher level, right? So we do, right? Let's say that you have a skull, different, you call parabola like this, Notice that they have similar shapes, right? And however, the intercept at different locations, right? They have a different shapes. Actually, they have a similar shape. That's what I'm trying to say. They have a similar shapes. I mean, I can I can do something like this, right? Notice that they are similar, right? They are similar. They are similar, right? Which means there is a family of solutions. Well, we call this general. We call it general solutions of the differential equation. Okay, so a general solution will only give it at some point. Okay. Okay, so the general solution, it will give an idea of the function. Okay. However, it's again a thing, right? It's good for analytical purposes, but it doesn't give me a solution at a certain point of time, for example. When this happened, at this point in time, what is the response of the system, right? So therefore, when I have an initial value problem, that means that an initial condition and initial condition in has been given, right? So an initial condition have been given, right? In other words, this function has a solution at this point, right? For example, right here, at x equal 2, right? The solutions will be, in this case, is going to be different. It's going to be negative, right? Right? But they all have a solution at that point. Now, the specific, so a solution at a specific point is called a particular particular solution. Okay? This is what I'm going to do here in this problem. Okay, let's get started. So, okay. So, So let's start with the problem statement. It says solve the initial value. So, okay. Now, let's go to this book. And we're doing problem number 17 in this book. Fundamental differential equations and boundary value problem. But this author is Nagel Seth Snyder, and it has a little apple there. I guess I don't know. Maybe the apple that fell and Isaac Newton had. I guess he want to become creative, right? I don't know. One is it's a good book, and also Isaac Newton. He was a good guy. He discovered some good stuff for us, right? So now let's do number 17 in this book. So the problem states that's the problem statement, right? The problem statement is now the problem is stay like this: y prime equal x to the third power, right? 1 minus y. Okay, so now um honestly I don't like this too much. What I like to do, I like to rewrite this as dy over dx, right? Because this is my x is just going to be change, the change in y, all right, with respect to x. Change in y with respect to changing x, right? Now, in other words, y depends on x, and therefore, the change on the x is affecting on the y, the change on the y, right? So now what I will do is write that as x cubed 1 minus y. And the reason I do it like this is because we have to follow. And in the past, I've done some problems in separation of variables, and it's important to write it like this, right? Anyway, so what I will do is separate the variables, right? Separate the variables, and I do the following. So dy, right, multiplying by dx, I get this on the other side, and I get x cubed 1 minus y dx. Now, I have not separated the variables yet. I have not separated the variables yet. What I will do is separate the variables, right? By seeing what is in here. Well, I have a multiplication, which is a good thing, right? Because the opposite of multiplication is division, which means that this problem is separable. But if I have a plus or minus sign in between here, then this is not separable. But I have this multiplying this, which is a product. That's what we want, right? To be separable. Now, divide the 1 minus y here, right? Why? Because they gotta be y. All right, so I will divide by 1 minus y, divide by 1 minus y, right? That cancels out, and I get dy over We say cancels out, but technically not canceling out, right? Divided, this is equal to 1. Divide itself, right? Like, technically, we use kind of, right? But anyway, so we divide by that, right? We divide by this term, and then we put that terms and the y, 1 minus y on this side. And this guy right here, right? We get x cubed dx. Okay. So now, now, now I will bring this here, and 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 we say that dy over 1 minus y equal equal x cubed dx. One thing is important to remember when we're doing this problem. If you have a ratio, any kind of fraction, you want to make it sure that whatever it is, dy or dc or d whatever, right? Whatever, is on the top. And expression, whatever, is at the bottom. Right? But the d sum, d is going to be at the top, right? If you have a fraction like this. Okay. So now, look what is this, right? So we have a negative here in the bottom, which is not too good for us at the moment, right? So we need to kind of do something with that. So what we can do is the following. So we can substitute, we can say u is equal to what? Is equal to this 1 minus y, and du is equal to negative dy. Now that we have this, we can start doing the next step, right? So I could actually do the u over here, and then we'll do the pieces. But what I want to see is if this negative makes any changes on the dy. That's I'm not going to use the u substitution for the rest of the integral, right? So what I can do now is to integrate. Now that I have this, and I know that the change it just was the sign on the dy. What I can do, and I can say is negative dy over 1 minus y equal to x cubed dx. All right. So now what I can do is take the integral of that, right? So take the integral of that on both sides, right? When I take the integral of this becomes, this part right here becomes the ln, right? The ln of this expression, right? And this, of course, when I take the integral of that, I add 1 to the exponent and divide it by this new exponent, right? So the left side right here becomes a negative ln of 1 minus y, absolute value. The integral of this is going to be the following. The integral of this, add 1 to the top and divided by the new exponent. And 1 to the third power is equal to raised to the fourth divided by 4. So it's going to be x to the 4 over 4 plus c, a differential equation because we might have a multiple solution to a differential equation. We call it C1. Eventually that might change. At the moment, that is we go by the C1, right? And in this problem, because the second derivative is a first order differential equation. Why is a first order differential equation? Because we have one derivative only, right? First order. So a C1 will be fine at the moment. Right? So now let's do this, right? So we have something right here. We have something that's called that negative ln, or normally, sometimes people just write this ln like this with the, with the lowercase. Negative ln, natural value of 1 minus y equal x to the fourth over 4 plus c1. Okay. Now look at this. Look at this. Now we have a negative. Again, mathematics, we don't discriminate unless you use it to discriminate, right? The discriminant is the only one that discriminates in mathematics. So, okay. So that is the only case where you have to do some type of discrimination in mathematics when you use the discriminant, right? But okay, so now when you do ln, right? So now to divide by 1, negative 1. And of course, that guy right there that gets negative 1 too. Then, right, the negative sign of y is by itself. And I got ln, the absolute value of 1 minus y is equal to x to the fourth over 4. Of course, it's negative now because it's divided by a negative. And a negative c. Now, what we're looking at, well, right here, I noticed something. I say that initial value problem, but I don't think I put the value of the okay, the initial conditions. Initial condition is at y evaluated to 0, the value of the function is 3. Initial condition, right? That is the initial conditions given, right? Now, this is the thing. Look here. I need to solve for y, right? Or to get rid of this ln, because I need to at least get rid of the ln for now. How do we get rid of the ln? By taking the e to the exponential expression on top, taking the e to that, taking the e to that. When it's the e to that, right? This becomes ln. The ln cancels out, right? y minus y times the volume equals e is equal to e e x x to the fourth over 4. And I get e to the minus c1. Okay, so now, now, if we look at this C1 can come to the front, and it's E multiplied to C to the C1, but since this is a constant, we can call it C. Okay, so E to the C1, and that is nothing, but we call that C because it can be any constant number, right? Now, we can bring that to the front, and we say that y1 minus y, absolute value, is equal to C, you call it C, e to the negative x to the fourth over 4. This is that I know that this is a simple constant. Then I can get rid of this actual value. And we gotta be careful because that's a negative C. A negative C still taking place over here. Now, if I divide it by C, let's say, for example, you divide it by C in this side, right? Divided by C in this side, you put a C right here. And then you move that to here. Take the absolute value of this, right? You pull it out, take the absolute value, that make that absolute value statement true, right? But taking the negative sign, let's say, for example, this negative sign, you move it over here, right? Now, what you do is take the absolute value of that. So, well, that's the same thing, right? So that's how you know that this can be written as y minus 1 equal to negative c, actually c, sorry, c, c e to the negative 4, right? And this is, okay, e to the fourth, this is e to the x to the fourth over 4, right? Is negative. Okay, now what do you do with this? You move this to the other side. Actually, you know what? This, you still keep the negative sign on this. Keep the negative. Keep the negative on the C. Right. Now what do? Move this guy to the other side. Solving for y, we have to move this guy to the other side. So you add, you subtract 1, right? Subtract 1, subtract 1. And we get negative y equal negative c, negative c, right? Negative c e to the x, negative x to the fourth over 4. Negative, and then subtract 1. No. Divide this by negative 1, negative 1 divided by negative 1. And this will be y equals right? Divide this guy by negative 1 too. Again, don't discriminate, right? It is going to be negative 1 over there, right? This negative 1 cancels out or divide each other out, right? And when I do it, that is equal to 1, right? Right? Negative divided by negative is a positive. Now that guy is equal to C e to the negative x to the fourth over 4. And then that guy right here plus 1. Plus 1. Now, this is be my expression that I will be using for solving my initial condition. Now, notice that he say that x equals 0, y is equal to 3. That's what it's telling me. It does not tell me that x equals 0. It's telling me that y evaluated are not a such number, which is 0, y equal 3, which is telling me that x equal to 3. It doesn't really directly tell me, but it's telling me that y evaluated a certain number is equal to 3, which means that x equal 0 and y equal 3. Okay, let's do it. Okay. So, see, let's do it here. Using this expression, let's do it. So, y equal c c e to the negative x to the fourth over 4. And this is, like I said, this is e. So e x negative x to the fourth over 4 plus 1. I like that. Like that expression. A certain requirement, right? I used to have a sergeant in the army that says, do the requirement of push-ups plus 1. This is the requirement plus 1. Now, which that was to test the PT test, right? Anyway, so now we do that, right? So y equal 3, right? C e to the negative x to the fourth over 4 plus a constant, plus constant 1. But now we know that x equals 0 at a point to the fourth power. And e is just a constant, right? And any number to a any number to a 0 power, right? Because this is equal to 0, right? So 3 is equal to c e to the negative 0 power plus 1. This is equal to 0 anyway. So, right? So e to the certain e to the the 0 power is 1. So therefore e3 equals c. C, if that is 1, then the c, right? It's just c plus 1. Now let's do this. Now let's subtract this back to solve for C. We want to solve for C, okay? Subtract 1, subtract 1, and we get what? We get the we get we get 2, right? We get 2 equal what? Equal to C. Next, we have the 2, right? And what with expression? With expression, C is equal to 2, and we substitute where we have a C over here. Now we will have coefficient in front of that E, right? Which means that basically that's what we found. We found the coefficient of that number right there, of that number E, right? Which is E it's just, E is just a number, right? It's a constant. But this, the solution for this is going to be the following. It's going to be y equal C, right? C is equal to 2, right? And it's going to be 2e to the negative 4, to the 4th over 4 in plus 1, plus 1. And that is the answer for the problem. If you learned something, just give me a like, right? Remember that over here at the Christian Engineering Academy, we learn something every day because Jesus is good. Thank you for watching, and I see you in the next video.